Please make sure you have your copy of the assignment Chemical Bonding and Conductivity, and please turn with me to the Procedures and Observations section on the almost last page. What I'll do is I'll go through how to conduct the tests that you'll work on in your groups. I'll demonstrate the first 4, and then you can do the next 12. When you go back to the lab bench, your group will be assigned to do some, not all, of the compounds. There's some cups that you can label with a marker and take to the supply table to get small samples of the materials that your group will test. A small sample is just a very small scoop to put into a cup. I'm going to test water and sodium bromide and potassium chlorate and phosphatidylcholine, which is the primary component of a mixture called lecithin. I have a flame here for melting substances that need to be melted and water to add to substances that need to be dissolved. Some of the materials are already liquids, so you don't need to add anything to them to test them. Now when we do the tests, what we're going to use is a little conductivity tester. It's a simple circuit with a 9-volt battery, a little resistor, and down in here there's a light bulb. It's shaded because you want to be able to see if it's bright or dim. And you can test your tester to make sure that it works by taking something metal, like a paper clip, and then there are 2 wires. You want to make sure not to touch the wires with your fingers because those stuff from your fingers can get on the wires and contaminate them, and then your results won't come out. So if you want to test something, touch the 2 wires, just the tippy tips, to what it is that you want to test. So if you test something metal, metals are good conductors of electricity, you'll see the light bulb down in there turn on real brightly. So now I know this one works. Now I'll do my first test. I'm going to test water just by dipping the wires right in the water, just the tippy tips of the wire. And when I put it in there, there's no result. That's because water is not a good conductor of electricity. If your light bulb goes on real brightly, then that means that your wires are contaminated, and you want to make sure that each time you do a test that you wipe the wires clean with a paper towel and make sure that the wires aren't touching each other, because that will make the light go on without doing any tests. So make sure that your light is not on when you're not testing something, and make sure when you dip the wires in water that the light doesn't go on, showing that the wires are clean. Water is not a conductor of electricity. But if you put things in water that are ionic compounds or electrolytes, then you'll see the light turn on. So for example, the next test, sodium bromide, I have a small sample of sodium bromide in this cup, and what I'll do is I'll add a squirt of my distilled water and mix that around, and then I'll do a test by testing I'll just dip the tippy tips of the wires into the sodium bromide mixture and see if the light turns on. There we go. The light turns on. So that means that I would record this as a good conductor. Sodium bromide has ionic bonds in it. It is an example of an electrolyte. I want to make sure that my wires are clean before I do the next test, so I rinse them off with the water and dry them off with a paper towel, and then I'm ready for my next test. The next test is sodium chlorate. Now in my instructions it says to melt some, so I put some in a test tube, and then I'll put the test tube over an alcohol burner flame until it's done melting. It shouldn't take too long to melt. There's some other substances that we'll test that need to be melted. For example, wax and sucrose. Sucrose is table sugar, so you can melt those in a test tube. And when they turn into liquids, then you can stick the wires down in and see if you can get them to touch the liquid and test it to see if it is a good electrolyte or not. Let's see how long it's taking for this one to melt. Alright, it's starting to melt down there, I can see. Okay, my sodium chlorate is melted. Potassium chlorate is melted. And now I'm going to put the wires down in there and test it. And I'll show you what the meter looks like. Let's see here, I've got the wires in there. And the light is coming on pretty brightly. So when melted, potassium chlorate is a good conductor. I didn't add any water to this, so I'm testing the pure substance. And when melted, this one has ions in it too. In the solid form, the ions aren't free to move around, so it's not a good conductor when it's a solid. Only metals are really good conductors in their solid form. Now I want to rinse off the wires and dry them off for the next test. When I'm done with that one, I'll just leave the test tube in the beaker to cool and let let me take care of that. You don't have to try to rinse it out with water or anything like that. It won't come out. Okay, the last one, phosphatidylcholine. It's already a liquid. Some things are already liquid, so you don't have to add any water to them and you don't have to melt them. So let me put the meter up here and touch the wires down to the phosphatidylcholine. And just the tippy tips are touching the liquid and there's no light going on. So this one would be recorded as a non-conductor. Non-conductors are molecular substances and they contain primarily covalent bonds. And so we'll record this one as a non-conductor. And I'll rinse off my wires again, make sure that it's ready for the next test. So when you go back to the bench, you'll do 6 out of the 12 compounds and record your results up on the screen for the rest of the class to see. If more than one group is testing the same substance, go ahead and circle your result more than one time so that we can show where we have consensus and where we have to double check our results up on the screen together. All right, so make sure that your goggles are on at the bench and let's go back and get to work. Okay, so let's take a look at the results of the experiment if you didn't get a chance to try it yourself in class. I have my conductivity tester here and some water to check and make sure that my wires are clean. And I'm going to make sure that my conductivity tester is working by taking this piece of metal and touching the 2 wires. And if you look in there, you'll see the light comes on. That means my tester is working. And so I'll test my water, make sure my water is pure. I dip it in the water. There's no light coming on, so that means that my water has nothing, no impurities. So I added the water to some of the substances that needed to be mixed. Other substances are already liquid, so I don't need to add water to them. Or they have to be melted over a flame. I'll show you what those are. So I'll go right through each one of the results. The first one here, potassium iodide. Some water was added to the solid material to dissolve it. And we put the wires in and we'll see what the light does. The light turns on, so we'll record potassium iodide as a good conductor of electricity. Let me rinse off my wires, make sure that that stays clean, and then I'll do my next one. Make sure the wires aren't touching each other. Okay, make sure they're clean, not touching, good. Okay, next one, number 2, is magnesium chloride, some solid crystals to which I added some water. And we'll double check here. We'll see what happens when the wires go in. Okay, another good conductor. All I'm doing is touching the tips of the wires to the mixture that's inside. Let me clean off my wires, make sure that that's not going to contaminate my next sample. Zinc nitrate, number 3. I already added some water to it, so I'll stick the wires down in. And there we go. We've got another good conductor here. So zinc nitrate. Rinse off my wires. Dry them off and get number 4, sodium aluminum phosphate, one of the main ingredients in baking powder. And I'll drop this in here. And okay, we've got a good strong light there, so that's a good conductor, number 4. All right, and then number 5, copper sulfate. Dry off my wires. Copper sulfate, also a good conductor. Okay, so the first 5, all good conductors. Now, let's take a look at number 6 and number 7. Number 6 and number 7, wax and sucrose, I have them melting over a flame. So what I'll do is I'll put the wires down into each of the test tubes. The one over here is the wax, and the one on the right is the sucrose sugar. When that one melts, it makes caramel. Alright, so I'll put the wire down into the wax first and check and see if the light turns on. And in goes the wire and light is off. So this is a non-conductor. Wax is a non-conductor. I'll pull up the wires, make sure to get the melted wax off of there. Okay, and then do the sucrose next. I'll put the wires down into the melted sugar. And now they're down in there. And the light is not coming on. So sucrose, a non-conductor. Okay, it's got that sticky sugar on there I got to get off. So let me rinse off those electrodes and dry it off. Okay, make sure the light doesn't come on. Good. Make sure my meter's still working. Light is coming on. Yep, good. Okay, so this is still working. All right, so let's continue. That was number 6 and number 7. Now we'll do number 8, vegetable oil. It's already a liquid, no water needs to be added. Dip my wires down in there and the light does not come on. So I'll record vegetable oil is a non-conductor. Clean that off. And do number 9, dichloromethane. This one is used as a solvent for cleaning off greasy stuff. Okay, put the wires down in there. And non-conductor for number 9. Number 9, non-conductor. And number 10, okay, acetic acid. This is vinegar. So I'll put the wires down in there. Oh, pretty good conductor. So number 10, acetic acid is a conductor. And rinse off my wires. Dry them off. Now number 11, ascorbic acid. This is vitamin C. Okay, that's a good conductor. So record that for ascorbic acid number 11. And then our last sample, number 12, citric acid, a sour flavor in fruits and candies. Good conductor. Okay, so you should have recorded those results on your copy of the assignment, and then follow the steps in the analysis and the questions to find out how to explain why some of these substances are good conductors or not, what it tells us about the kinds of elements that make the two types of bonds, ionic bonds and covalent bonds.